As you will see in the first couple of pages of our textbook, systems are important to understanding science and many other things, but the book doesn't spend as much time as it should explaining systems. We'll certainly be seeing more of systems all the way through the book. Since we're just beginning to talk about high school biology and we haven't learned much biology yet, we're going to start learning about systems using something you already know about, the Wahluke Irrigation System. I'm also going to try to show you how I went about learning how this system works. Some of the things we're interested in when we think about systems are inputs, or what goes into the system, outputs, what comes out of the system, boundaries, where are the edges of the system, what parts are inside and what parts are outside, subsystems, that is, parts of the systems that can be looked at as their own systems, how different parts of the system affect each other, and this includes the ideas of feedback and homeostasis. We're interested in the things the system can do that the parts can't do alone. These things are called emergent properties. And we're interested in what larger systems our system is part of. Thinking about systems lets us make models. Models are things that help us understand a system by breaking it down into pieces or smaller parts. Models can take lots of different forms, and we'll look at a few examples. Best of all, once we understand a system and we have a model of it, we can try to make the model work better in a different way. But first, let's learn about the Wahluke Irrigation System. There's a really surprising thing about the Wahluke Irrigation System, and that is where the water comes from and how the water gets up onto the east end of the Wahluke slope. So we're going to start at the end of the system, that is where any water that's left over in the system goes back into the Columbia River, and then we're going to go to the beginning, and then we'll look a little bit at the middle, and then we're going to build a model. Okay, I wanted to come to the end of the Wahluke Irrigation System, and here we are. The water that's left over from the irrigation system after it goes all the way through from the other end to here goes into this lake. And if you look on Google Earth or something, you see that the lake goes off in that direction for a ways, and then the water ends up going back into the Columbia River where it started, way back up there. In fact, outside of the system that we're talking about right now. This is what the last part of the sort of built system looks like here, and now we're going to go find the other end of it. To find the place where the water comes up onto the east end of Wahluke Slope, we have to go nearly 40 miles. We go almost until we get to Othello, and then we take a right and go back up the hill, and we wind around a little bit until we find the very beginning of the Wahluke Canal, the canal that brings all of the water to all the farmland around Mattawa. Well, I came looking for the beginning of the Wahluke Irrigation System, and this is almost the beginning. This is where the water comes into the system, but I can't hardly believe how the water gets here. Check this out. I'm going to walk down the road a little ways here and see if I can use the other camera. What you see down there is how the water gets up here. It's pumped into that pipe from a pumping place down around the corner, I guess. I'm going to try to get a look at that. And it's pumped up this hill. We must be, 100 feet easy above the level of that pipe. And the water comes out here. And then there's a gate that manages the level of the water off in that direction. That's the water that heads down toward Wahluke High School and the Columbia River. Well, I'm up the hill a little bit with a little bit better view of the beginning of the canal that goes off toward Wahluke, and a little bit better view of where that water comes from. I still don't see the pumping station. It's at the other end of that pipe somewhere. I don't know if I'm going to be able to find it or not, but we'll go try one more place. I finally figured out where the water was coming from by following the pipe using Google Earth. And I had to follow the pipe for, I think, almost 4 miles. And the reason I had been confused about where the water comes from is I had been looking for a pumping plant, which involves a really big building that has a lot of electricity, great big electrical wires, power lines going into it to provide enough energy to run the pump, to pump the water. And it turns out that that's not how this part of the system works at all. It doesn't involve pumping, it just involves gravity. And where we're going to get to here is a place on a canal that starts out up at O'Sullivan Dam. The water comes out of O'Sullivan Dam Lake, runs in a big canal down past Othello, and then finally ends up here where some of it heads up toward the Wahluke slope. It turns out that this whole system is what's called an inverted siphon. And the place where I'm standing is at an elevation of about 1,000 feet. And over on the other side there, the elevation is about 965 feet, where the water comes up out of those pipes, or out of that one pipe, and into the Wahluke Canal to continue on the Wahluke Irrigation Project. Crazy, huh? And here you can see the water leaving the Wahluke Canal and going through the gates and down into the pipe that is the inverted siphon. And the inverted siphon takes the water to the other side of this valley and puts it into the ditch that ends up going right past Wahluke High School. Now from here, you can't see very well because of the smoke from a fire up between Ellensburg and Yakima, but you can see why they call it the Wahluke Slope. We're actually 200 or 300 feet higher here than the town of Mattawa is. And the big ditch is wide enough that the wind actually kicks up weight caps on the ditch, and it's going to drop maybe 1/4 inch per mile. That's how it's engineered, is to go down 1/4 inch per mile as it moves out toward where the farming is. And in the foreground here, you can see what this whole area would look like without this ditch. It would look like desert. That kind of desert out there is called sagebrush steppe, and we'll be talking more about that. So here we are at the circle irrigation system in the field next to the high school. This is a field full of buckwheat, and the water that's coming out of the nozzles behind me started out way back up where we have seen there at the Wahluke siphon, the Wahluke Canal that comes from O'Sullivan Dam, and then the Wahluke Canal that comes all the way down here by the high school, some, I don't know, 15 or 20 miles away. I have made a model of the entire Wahluke irrigation system in my backyard. We've talked about how models are really important in science, and here's an example of a model that wasn't too hard to build. I don't know, it took me a half hour or so. Let me show you the parts, and then we'll use it. So here's a piece of gutter. And the gutter's got a place for water to come through. This would normally be a downspout if it were really a gutter. And a funnel, and one end of a garden hose. And then the garden hose goes all the way over here, about, I think it's about 75 feet. Goes up over that blue box. And I'm starting to understand why people speed up parts of these videos. And the other end of the hose goes up this other ladder and into another piece of gutter. The water is going to come out there, and it's just going to run out on the ground down here. Now, this is about a 1/200th scale model. In other words, the real thing that we've seen now is only about 200 times bigger than this. The real thing is a little bit over a mile and a quarter long, and it ends at 965 feet above sea level. This is 1/200th of 965 feet. The ground is sea level. And the other end down there, it starts at about 1,000 feet above sea level. And 1,000 divided by 200 is 5. And the other end of the hose is about 5 feet off the ground. So let's see how it works. I have tried to make this so that if we put water in the other end of this piece of gutter, it both runs off the near end of the piece of gutter and into the funnel, which goes into the pipe, which goes into the hose, which goes over to the other ladder. So that's working pretty good. We've got water running off the end of the gutter and water running into the hose. We'll go over to the other end here. So I don't know if you can see that, but water has just started coming out of the hose, and it's running down the gutter and it's running off the end of the gutter down onto the ground. And let's see if we can get the whole system in one shot here. Okay, there it is. That's our model of the entire Wahluke irrigation system from the beginning of the inverted siphon all the way to the end. This is a nice model of the entire Wahluke irrigation system from the beginning of the siphon to the end of the project, the end of the system where the water goes into that little lake. Let's take a look at the elevations. We start here. The beginning elevation really is about 1,000 feet. We didn't quite get to it here. And the siphon goes down, and then it has to go up this little bump. And the blue box in the model that I made in my backyard is what represents this bump that the siphon has to go over. Now, look at the elevation at the beginning of the ditch on the Wahluke slope. We're at 970 feet here, and the ditch follows the contours of the land around. Whoops, it follows the contours of the land around until here. After about 32 miles, it took about 32 miles to get to the beginning of farmland near Mattawa. And then finally, just before it drops over the edge down to the river, the elevation is 937 feet. In other words, the elevation has changed by only about 40 feet, maybe a little less than 40 feet over the more than 40 miles of canal that it has taken to get here. I said earlier that I thought that the project was engineered to drop a 1/4 inch per mile. That turns out not to be true. It's more like about 1 foot per mile. And then finally, the water drops off the edge of the slope and goes down to the Columbia River at an elevation of just a little bit over 500 feet. We went from 1,000 feet to 500 feet, but most of the irrigation happens between 933 feet and 971 feet.